This video is for The Living Earth, Unit 3.3, Evidence for Plate Tectonics. Today's essential question is, what evidence supports the theory of plate tectonics? Our first main idea, Wegener's evidence for continental drift. Scientists are gaining more knowledge about plate tectonics every day. However, the theory of plate tectonics is a relatively new one, becoming widely accepted in only the 1970s. One of the things that scientists noticed that supports plate tectonics is the apparent fit of the continental coastlines. This is particularly apparent in the way that eastern South America and western Africa seem to fit like a jigsaw puzzle. This evidence led to the hypothesis of continental drift, which was developed in the early 1900s by a German scientist named Alfred Wegener. Wegener marshaled a variety of evidence in support of his idea that the continents may once have been joined. And here are his top 3 pieces of evidence. 1. Similar landforms are distributed across oceans. For example, mountain ranges sometimes appear to be continuous on opposite sides of an ocean. The Appalachian Mountains in North America and the Catalonian Mountains in Greenland and northern Europe formed when all 3 land masses were joined in the supercontinent Pangaea. And as Pangaea broke apart, what had been a continuous mountain range broke apart as well. Today, these mountains are separated by the Atlantic Ocean and several smaller northern seas. These rock sequences have also been matched on opposite sides of the ocean in other locations. 2. Wegener noticed that deposits of glacial sediment have been found on opposite sides of the ocean as well. The position of these glacial deposits did not make sense with the continents in their current positions. Continental drift seemed to be the only explanation for their distribution. Number 3. Similar fossils have been discovered in distant locations. The mosasaur fossils found in Brazil and Western Africa are only one example of this phenomenon in addition to many more. Paleontologists continue to find more and more fossils that match on opposite sides of the ocean. Our next main idea, evidence for plate tectonics. Initially, the hypothesis of continental drift was rejected. This was because Wegener could not determine the mechanism by which the continents drifted together and apart over this geologic time. Wegener died in 1930, before scientists truly began to accept his ideas. Technological advances have allowed scientists to more thoroughly explore the ocean floors. Using new, sophisticated instruments, they began to understand this mechanism. Scientists realized that Earth's surface is divided into tectonic plates, containing both continental and oceanic tectonic plates. The hypothesis of continental drift then became incorporated into the theory of plate tectonics, and scientists use Wegener's evidence supporting continental drift to support the theory of plate tectonics. Scientists also discovered further evidence of plate tectonic movement. Plate tectonics is supported by the relatively young age of the oldest oceanic crust. Earth's crust first solidified approximately 3.85 billion years ago. Earth's crust is constantly recycled through the process of plate tectonics. If it were not, all of Earth's crust would be expected to be the same age, approximately 3.85 billion years old. Yet, new continental crust is continually being formed at seafloor spreading centers. Older crust is continually being destroyed at subduction zones. Therefore, the oceanic crust that exists today is only around 200 million years old, much younger than the age of the continental crust, which can be much older than 3.85 billion years. Seafloor spreading centers provide other evidence for plate tectonics as well. Scientists can observe where the oceanic crust used to match up. This oceanic crust has now been pushed apart on either side of the mid-ocean ridge. Scientists have discovered the symmetrical age patterns of oceanic crust on either side of these mid-ocean ridges. They have also discovered symmetrical magnetic reversal patterns, and these matching patterns show very clearly evidence that the oceanic crust is moving apart at a divergent boundary like the mid-ocean ridge, at which magma wells up between the two moving plates, forming new crust. Scientists can directly observe new crust being formed at sea floor spreading centers. They can then infer that older crust must be destroyed elsewhere on the planet. Otherwise, Earth would be expanding. Observations of old crust being destroyed at subduction centers seem to confirm these hypotheses. Plate tectonics is also supported by precise measurements of relative plate motion. Scientists can use global positioning systems, GPSs, and other devices to track the movement of tectonic plates. Scientists now know the average rate of movement of each tectonic plate. Some of the plates move faster than others, but the average rate of plate movement is just a few centimeters per year. At this point, you should be able to generate a full and appropriate response to today's essential question: what evidence supports the theory of plate tectonics?